Number 10 asks us to solve the following system of equations. All right, so first thing we have to do is we have to get one of the variables by itself in one of the equations. All right, so if you want to get, I guess if you take a look at this second equation, it looks like y is going to be the easiest variable to get by itself. So if you just subtract 3x from both sides of the equation, it leaves you with negative y equals negative 3x plus 3. And then just divide both sides by negative 1, so you're left with positive y equals positive 3x minus 3. So since y is equal to 3x minus 3, we can take this 3x minus 3 and replace it for y into the other equation. So instead of having 9x squared plus y squared equals 9, we're going to have 9x squared plus 3x minus 3 squared equals 9. Okay, so what we've done is we've created an equation with one variable, so we could solve now. I'm going to bring the 9x squared down, and 3x minus 3 squared just means 3x minus 3 times itself. So let's write it out twice. And let's double distribute. So I'll bring the 9x squared down, and when I double distribute, I get 9x squared minus 9x minus another 9x plus 9 equals 9. All right, so we can combine our like terms. 9x squared plus 9x squared is 18x squared. Negative 9x and negative 9x is negative 18x. And then we know we're going to have to get one side of the equation set equal to 0, so I'm going to actually do this all in one step. When you subtract 9 from both sides, what's going to happen is they cancel off of both sides, so we're just left with equals 0. All right, so just factor, t-chart, and solve for x. So you can factor out the GCF, which is 18x, and when you do, it leaves you with x minus 1. So when we make our t-chart, I mean, you could, if you want to show the work for it, you could take 18x and set it equal to 0, and when you divide by 18, you're left with x equals 0. On the right side over here, we know we're left with x equals 1. So that 0 kind of looks like a 2, so I'm going to actually just make that a little neater. Okay, so what we know is these are the x-coordinates of our points of intersection. So we know that one of our x-coordinates is 0 and the other one is 1. Now what we have to do is we have to find the y-coordinates that go along with these. So you can go back to any equation you want, but I think this one, y equals 3x minus 3, is probably the easiest because y is already by itself. So let's use that, y equals 3x minus 3. And I'm first going to replace this x with a 0. So we'll have y equals 3 times 0 minus 3. Well, 3 times 0 is 0, and 0 minus 3 is negative 3. So what that means is when x is equal to 0, y is equal to negative 3. So 0, negative 3 is one of our points of intersection. All right, then let's do it over here. So we have y equals 3 times, this time we're going to replace the x with a 1. And since 3 times 1 is 3 and 3 minus 3 is 0, what that means is that when x equals 1, y is equal to 0. That is our other point of intersection. In this question, we have to solve the following system graphically. So what we're going to do here is, let's just graph one equation at a time. Let's start with the linear equation. So what we want to do is we want to get y by itself. So in order to do that, I'm going to add 2x to both sides of the equation, leaving me with 2y equals 2x plus 4. And then when we divide both sides by 2, we're going to be left with y equals 1x, or just x, plus 4 divided by 2, which is 2. So I'm going to graph this using the slope-intercept method. So the slope is the number in front of the x, so 1, which we want to make into a fraction, so I'll write that as 1 over 1. And the y-intercept is the constant at the end of the equation, which is 2. Okay, so let's just first plot some points. So we're going to start at the y-intercept. Since the y-intercept is 2, you can go on the y-axis and put a point at 0, 2. And then since our slope is 1 over 1, to graph more points, you're just going to go up 1 into the right one, put another point, up 1 into the right one. And you could do that a few times. I mean, if you want to go in the other direction, you can. You can go back to your original point, and you can go, instead of up and to the right, you can go down and to the left. So it's just kind of following in line with those other points. Okay, so now you can take your ruler and you can, oh wow, okay. I'm going to have to move that over, but you can just connect those points and make sure to put arrows and to label. You can either label the original equation or you can label y equals x plus 2, whatever you prefer. 2y minus 2x, I'm just labeling the original, equals 4. All right, so now let's go to our circle. Our circle, what we have to do is we have to take that equation and we have to rewrite it in center radius form. So in order to do that, we have to complete the square. So first you're going to take your x's and group those together. And let's put an empty box. We'll fill that in a minute. Then we're going to take our y's and group those together with an empty box. And on the right-hand side of the equation, I'm going to have to kind of squish this. We're going to have the 4, but we're also going to add to that 4 2 empty boxes, because whatever we add to the left-hand side of the equation, we have to add to the right to keep it equivalent. All right, so in order to find the number that goes in the first box, we look at the term before it. And when you look at the coefficient, we have a negative 4. You want to take half of that and then square it. So half of negative 4 is negative 2, and negative 2 squared is positive 4. So we're going to add 4, make sure you write the plus sign, to both sides of the equation to keep it equivalent. Okay, now if we look at the second box that we have, we're going to have to look at the term before that. So we have a negative 2. We're going to do the same thing. Half of negative 2 is negative 1, and negative 1 squared is positive 1. So we're going to add 1 to both sides of the equation. All right, so I'm going to start with the right-hand side of the equation. When you add the 4 plus 1, that gives you 9. And over here, we're going to take these two trinomials and factor them. So x squared minus 4x plus 4 factors to be x minus 2 times x minus 2, which we can rewrite as x minus 2 squared. Okay, let's bring down the plus sign. Y squared minus 2y plus 1 factors to be y minus 1 times y minus 1, which we could rewrite as y minus 1 squared. We'll just bring down the equals 9. Now our circle is in what we call center radius form. You can tell by looking at it what the center is and what the radius is. So our center is going to be positive 2 and positive 1. And our radius is just the square root of 9, which is 3. All right, so now if we want to graph this, I'm going to first just put a point at the center. So at 2, negative 1. At 2, positive 1. And since our radius is 3, I'm just going to go up 3. I'm going to go back to my center and go to the right 3. I'm going to go back to my center and go down 3. I'm going to go back to my center and go to the left 3. Now, you would use a compass to connect these. I mean, I don't have the ability to do that on here, so I am going to freehand a really bad circle here. And I'm also going to remember to label it. You can label it the original equation, or you can label it what you got when you wrote it in center radius form. It doesn't matter. But now we have to find our points of intersection. So it looks like my first point of intersection is right here at negative 1, 1. So let's write that down. And it looks like my second point of intersection is over here at positive 2, 4. Okay, the final question of our review sheet asks us to determine the values for all of the variables in the following system. Okay, so first thing we'd like to do is just label our equations A, B, and C. So we'll label this A, this B, and this C. All right, so we want to try to create two equations in terms of two variables. So in order to do that, I mean, if you look at your original equations here, if we look at equation A and equation B, see how we have a negative C and a positive C? If we combine those two equations, those C's will cancel off. So I think that's probably a good idea to start by doing that. So I'm going to take equation A and equation B and just rewrite them. So I have 2a plus b minus c equals negative 5. And we have 4a minus 2b plus c equals 10. Okay, so 2a plus 4a is 6a. b minus 2b is negative b. And like we said, the c's cancel off, and negative 5 plus 10 is 5. So I'm going to call this equation D. So this is our first equation that we created in terms of two variables. All right, now what we have to do is go back to the original equations, and we've already used A and B, so we can't use that pair. So we can either use A and C or B and C. And what we need to do is we need to kind of manipulate them a little bit in order to create another equation in terms of just A and B. So we need to, again, get rid of the C's. So I'm going to use A and C, because if you look at A, we have a negative C, and if we look at C, we have a positive 2C. Well, if I multiplied equation A by 2, then we'd have a negative 2C and a positive 2C, which are going to cancel off. So let me do that. Let me first write equation A and equation C. So when I take equation A and equation C, okay, like we said, we're going to have to multiply equation A by 2. Because when we do that, I'll just bring that right over here, we're going to have 4A plus 2B minus 2C equals negative 10. And let me just bring equation C right over. What's going to happen is the C's are going to cancel. So we'll have 6A plus 5B equals negative 7. And I'm going to call that equation E. So if you take a look at equation D and at equation E, they both contain just A's and B's. So when we have two equations in terms of two variables, we can now solve for one of those variables. Now I'm going to take equation D, and I am going to rewrite it under E. And what you'll notice is nothing cancels off, but if we multiply one of these equations by a negative, then we'll have a positive 6a and a negative 6a, which will cancel. So let me just take equation D, and I'll multiply that by negative 1. All right, I don't know if I'm going to have room, but I'm going to try to just take these equations and bring them over. So equation E, we're just leaving alone. And equation D, we're multiplying by a negative. So we're going to have a negative 6a, a positive b, and a negative 5. All right, so our a's cancel. 5b plus b would be 6b, and negative 7 and negative 5 is negative 12. So now, if we just divide both sides by 6, we found our b, which is negative 2. Now keep in mind, before you start one of these problems, it's really a good idea to, to plug this in your calculator as a matrix. And that way you can find out the solutions before you begin. So as you go through the problem, you'll be able to know if you're getting the correct values. So I actually did this in my calculator first, and I got A to be 1/2, I got B to be negative 2, and I got C to be 4. So far we're on the right track. B is matching up. All right, so at this point we can go back to one of the equations we created in two variables. So either the D or the E. And since we know B, we can use either one of those equations to help us solve for A. I'm just going to use this equation right here, D. So where can I fit it? Over here. So in equation D, instead of 6a minus b equals 5, we're going to replace that b with a negative 2. So 6a, well, minus negative actually becomes plus 2. And so now when we solve this, we can subtract 2 from both sides and divide by 6. And again, when I did it in my calculator, I wound up with a being equal to 1/2, so it's looking good so far. All right, the last thing we have to solve for is C. We found A, we found B, and to find C, you can go back to any one of the three original equations. I'm just going to go back to the first one, so it'll be 2a plus b minus c equals negative 5. I probably should have used equation B because it's a plus c, but it doesn't matter. We could solve either way. So I'm going to replace my a with the 1/2. I'm going to replace the b with a negative 2, and I'll bring everything else down. All right, so 2 times 1/2 is just 1, so we have 1 minus 2 minus c equals negative 5. 1 minus 2 is negative 1, so we can add 1 to both sides. So we're left with negative c equals negative 4. And when you divide both sides by negative 1, that's going to leave us with c equals positive 4.